So it's been now a week since these batteries were installed, the Lifepo4 ones, and they've been working really well and they've stayed reasonably well on balance too. What I'm doing just now is feeding power back into the electric car while it's charging, and that's working quite well. We've got 340 watts coming in from the sun, and the battery is also supplying some power too, and that's what I do. Sometimes at night I'll feed power back in to the grid at night, but it's mostly just when the car is charging, and it works really well. And when I had the lead acid batteries, the inverter would switch on and off quite a lot, just because whenever you put a load on lead acid, its voltage drops quite fast, and I was trying to not discharge the lead acids too much, but with this, the inverter stays on quite a bit longer, and it'll take about, I don't know, 600 watt hours out of the Lifepo4 bank. I'm just doing it by voltage set points, but this thing is 0.5 volts out. It actually reads the volts about 0.5 volts higher than it actually is, but I've compensated for that in my settings. So the inverter will come on when the voltage of the battery reaches 27.1 minus 0.5, which is 26.6 in reality. But remember, this is reading 0.5 volts higher than it actually is, and I can't seem to calibrate it at all. These potentiometers are for current calibration, and it goes off when the battery gets to 25.7. So take 0.5 off that, that's about 25.2. So that means that it doesn't fully discharge the batteries at all. I've sat and watched it via the camera just while that's happening, and again, it only take about 600 watt hours out the battery when it's fully charged, and that seems fine doing it by voltage. But what I'm going to do is eventually modify my data logging watt meter project, and eventually have that telling me how much power is in the battery. So basically what will happen is, when the battery is at the fully charged voltage of 28 and the current going into the battery is quite low, that means it's fully charged. So I'll show a fully charged graph, and then as I take current out, I could just count up the amp hours taken out and then have some sort of graph. But the inverter, yeah, it's pulling about 21 amps from the battery, and 522 watts is coming out. And this is where it's going. I've set the car to charge on low, which is it's usually about 1200 to 1400 watts. So just under half the power going into the car is coming from solar and stored solar. And I'll just have the car charging for a few hours like that. But yeah, power production recently has actually been pretty good, and these Lifepo4 batteries have made a good difference. I can now produce more power. So yesterday was a 2.4 kilowatt hour day, and it's still just February, and that's the most I've produced this year. As you can see, as we go back, it just goes down and down. So it's doing really well, and that is because say the sun is producing a lot of power, the panels are producing a lot of power on the lead acid batteries. When this inverter would switch off when it reached the low set point that it would set, the voltage would rise up again really fast on the lead acids, back up again to about 30 volts, because I set it to that, but when it's usually quite cold, roughly 30.5 volts for temperature compensation, and it would get back up there really quick. And then it would eventually get to the fully charged voltage, and the solar charge controller would reduce power output, and then the inverter would come on. But this ramps up the power very slowly, this inverter, so I was losing maybe about 30 seconds to a minute of solar power production while this thing switched off and on regularly, and I'd lose probably a decent bit of power every day because of that. I'm not sure how much, but I'd maybe be losing about 300 or 400 watt hours at least. But these, because of their relatively low internal resistance, if you switch off the inverter, the voltage just doesn't rise all that much at all. It goes up about a volt, and my fully charged voltage is 28 volts, so it's got quite a way to go. And obviously having these at partial state of charge, they prefer that. But one other thing that's worrying me is temperatures have been low recently. These batteries have been sitting at 2 degrees Celsius overnight, and if they were to go down to 0 and I was to charge them, they'd get damaged. So what I'm going to do is, when it becomes night time, I'll just connect the charge controller to the lead acid batteries, and I'm going to take every single cell out of here and I'm going to build a heating element in the bottom. It will be about 10 watts.